PiPhone manufacturing kicks off with the procurement of aerospace-grade raw materials, specifically lightweight space-grade aluminum.
Every batch of custom-designed microprocessors destined for the PiPhone undergoes rigorous quality assurance tests.
The import and inspection of specialized quantum dot nanomaterials are completed, which will form the transparent layer for the PiPhone's
Highly complex, 5-axis CNC laser cutting machines are precisely calibrated to etch and embed the polished
verification of the absolute purity, 99.999% gold, of the gold wire bonds used within the PiPhone's high-speed interconnects.
The production floor designated for the PiPhone assembly is continuously monitored and maintained as a Class 10 cleanroom environment.
Under controlled atmospheric conditions, the tiny voltage regulators and power management ICs are soldered onto the PiPhone, ensuring
the attachment of the 5G cellular modem and the unique Starlink modem chips to the PiPhone motherboard occurs in a finely tuned
reflex. First comprehensive automated optical inspection uses multiple high-resolution cameras to scan the PiPhone motherboard for
A phase-change, non-conductive coating is applied to critical hotspots on the PiPhone motherboard, actively managing heat dissipation during sustained heavy computational tasks.
The surface of the PiPhone screen receives a proprietary thin-film self-healing nano-coating application in a controlled mist.
the final transmitter pillage is so transparent layer.
An 11-stage perimeter sealing process is executed on the PiPhone display assembly edges using industrial-grade elastic.
Femtosecond layers. With the microprinted footprint detergent microphone splashed into the Nivian's bone canal complex sensor array.
Chines. The display controller's input latency is vigorously tested to ensure the PiPhone offers sub-10 ms touch response rates.
The battery is sealed into a fire-retardant structural polymer casing and securely installed into the PiPhone's frame with charging dates. The USB-C charging port assembly for the PiPhone is robotically soldered to the power distribution board.
The accelerated cycling confirms the degradation rate is well within acceptable limits.
Excellent. We are ready for mass production.
The Pi-phone's Quattro rear camera system lenses are cleaned using nitrogen gas jets and then sterilized. The complete camera unit assembly is sealed with a durable, compressible gasket before being installed into the back panel.
A tiny, heatsink-equipped thermal control sleeve is fitted around the Pi-phone's primary.
Pi-phone, begin recording. Check spatial separation. How well is this handling the ambient crowd noise now?
The final, ultra-hardened protective glass layer is adhered to the back panel of the Pi-phone, encasing and protecting the sophisticated camera lenses.
The unique, flat-panel, phased array antenna module, key to Starlink connectivity, is precisely mounted within the upper section. The Pi-phone's high-power Starlink assembly is wrapped in heavy-duty electromagnetic interference shielding foil.
The outer metallic frame of the Pi-phone is laser drilled with microscopic nanoslots, which are then filled with dielectric.
The Pi-phone antenna system is placed in a vacuum chamber and subjected to rapid depressurization, ensuring reliable performance.
A comprehensive coexistence test ensures that the various wireless systems, Wi-Fi 6E, Bluetooth 5,
The core Tesla-developed OSIM.
The Pi-activation Pi-phone software is calibrated to be.
Run Level 9 diagnostics on the biometric interface. Push the encryption protocols to maximum load.
All remaining microgaps and seams on the Pi-phone exterior are meticulously filled with industrial-grade polymer glue.
The various structural segments of the Pi-phone exterior casing are joined using high-frequency ultrasonic welding, creating seamless.
Structural integrity of the Pi-phone's casing is enhanced by utilizing internal equivalenter. Where screws are absolutely essential, robotic torque drivers are used on the Pi-phone assembly line, applying precisely
molecules. The PiPhone's dynamic thermal management system is monitored live, tracking the temperatures under continuous Starlink data transfer.
Simulation complete. 5-year equivalent analysis finalized. Capacity retention, 92%.
The PiPhone provides real-time vehicle commands. We registered a latency of just 1 millisecond, ensuring safe operation.
Precise robotic placement ensures the Starlink eSIM activation voucher and the custom reinforced charging cable are correctly nested within the PiPhone's minimalist box design.
If requested by the customer, a high-precision laser engraves the personalized text onto the metallic portion of the PiPhone backpack. Campus. Each PiPhone box is sealed using a unique, serial-numbered, tamper-evident security seal, providing the customer with
all quality control data, test results, and robotic calibration logs for the manufacturing of the PiPhone.
Final microcaliper measurements confirm the PiPhone's overall dimensions, ensuring the device's weight and thickness are within the
Specialized freight containers are utilized for the PiPhone, ensuring a strict thermal-controlled environment to protect the
The loading process uses automated systems to ensure specialized packing materials are correctly placed around the PiPhone.
Consistent with Tesla's mission, the outbound logistics prioritize the use of environmentally friendly transport methods for the initial leg of the PiPhone's journey.
The PiPhone officially leaves the manufacturing plant, beginning its highly anticipated journey toward the customer's doorstep.